In this video, we're going to be taking a look at numbers 16 and 17 on the Newton's second law review. Number 16, a 2.1 times 10 to the negative fourth kilogram spider is suspended from a thin strand of spider web. The greatest tension the strand can withstand without breaking is 2.2 times 10 to the negative third newtons. What is the maximum acceleration with which the spider can safely climb up the strand? We need to get our picture drawn. Here's my spider. The tension goes upward. The force of gravity goes downward. The mass is given at 2.1 times 10 to the negative fourth kilograms, and we know the tension, the maximum tension that this strand can withhold is 2.2 times 10 to the negative third newtons. We want to know if you pull the maximum amount that this strand can hold, what would be the acceleration that the spider could have going up the strand? So I'm going to set up my equation. Tension goes upward, and while gravity goes downward. So it's tension minus force of gravity, and that's all going to equal ma. Solving for acceleration, we're just going to divide by the mass. So tension minus force of gravity over m equals a. Plugging in my numbers, tension is 2.2 times 10 to the negative third newtons. Force of gravity is the mass, 2.1 times 10 to the fourth kilograms times 9.8 meters per second squared. And we're going to divide that by the mass, which is 2.1 times 10 to the fourth kilograms. Plug all that in your calculator, and you find out that this spider can accelerate up the strand 0.68 meters per second squared maximum. Moving on to number 17. So for number 17, an 85 kilogram man lowers himself to the ground from a height of 10 meters by holding onto a rope that runs over a frictionless pulley to a 65 kilogram sandbag. With what speed does the man hit the ground if he starts from rest? So here's my picture. It's an Atwood's machine. The man's on the one side. The 65 kilogram bag of sand is on the other side. And here are the forces. On the bag, there's tension up, and the force of gravity acting on the sand going down. For the man, the tension goes up and his force of gravity goes down. I call this F of G S for the sand and F of G M for the man. I'm going to say that if this system moves clockwise, which is the way that it's going to go, the guy is going to fall downward, then I'm going to say that's positive. The numbers that were given in the problem, I know the displacement is 10 meters. It's positive because it's going to be in the clockwise direction. His initial speed is 0. I want to know how fast he's going when he hits the ground, and I know both of the masses. The guy is 85 kilograms, while the sand is 65 kilograms. I need to set up an equation for each object, the guy and for the sand. So for the man, his force of gravity is positive because it's moving in a clockwise direction, while the tension goes in the opposite direction, it is negative. So that's going to equal his mass times the acceleration. The sand, the tension is positive, while the force of gravity goes in the counterclockwise direction, so that would be force of gravity is minus. That's all going to equal the mass of the sand times its acceleration. Now, these two accelerations are the same because the two are tied together by a rope. The guy cannot fall faster than the bag of sand moves upward. So we're going to add these two equations together, and when we do that, the tensions will cancel because one is negative and the other one is positive. So what that's going to leave me with is force of gravity of the guy, the man, F of G M, positive, minus force of gravity of the sand, because we got to keep our signs, so minus F of G S, and that's going to equal mass of the man times acceleration plus mass of the sand times acceleration, because I just added the two MAs together. Solving for A, I want to factor that out, and that leaves me with my M's in parentheses, and now I can divide them over to the other side. So I'm left with the two forces of gravity, force of gravity of the man minus force of gravity of the sand, divided by the two masses put together. I'm going to plug in my numbers. Force of gravity of the man is 85 kilograms times 9.8 meters per second squared. Force of gravity of the sand is 65 kilograms times 9.8 meters per second squared. And we divide that by the two masses, 85 and 65 kilograms added together. And that gives me an acceleration of 1.31 meters per second squared. They might have said, wait, we're trying to solve for the final speed. Why are we looking for acceleration? Because in kinematics, which is where I'm going to be getting final speed, I only have two other variables. I have d and I have v naught. So I needed a third one in order to actually get the final speed. And the only one that I could get is acceleration, because that's what forces in kinematics have in common. So now I'm going to use this equation, because time is the thing that we don't have and don't care about, which is vf squared minus v naught squared plus 2ad. V naught is 0, so it just cancels out, leaving me with vf equals the square root of 2ad Plugging in my numbers, 2 times A, 31 meters per second squared, times D, which is 10 meters. I do the square root of that, and I get his speed when he hits the ground is 5.12 meters per second.